Good evening. My name is Scott Payne. This is my presentation on Article 2 review. The article I chose was the Fairy Sequence, subtitle From Fraction to Fractals. Let's go right into it. So the topics I'm going to cover here in the next few minutes is what is a Fairy Sequence, and within that, what do we mean by forward circles, and how do we connect these things together in fractal geometry. I'll talk a little bit about a math history connection that I saw, my reflection, and then obviously give you an article citation so at some point that you can go and check it out yourself. So what is a Fairy sequence? Well, simply put, it's just a sequence of fractions between 0 and 1. The key thing, though, is how it's created. It's created using a mistaken sum we call a mediant of A divided by B and C divided by D. So, in other words, in grade school or in elementary school, when you start learning fractions, right, you would say A over B plus C over D. Well, you would find a common denominator, and then you would proceed forward from there. But in a mediant, we are taking the numerators, adding them together, taking the denominators, adding them together, and getting a new fraction. So let's look. So if I take, let's just say 0 and 1. If I take the numerators and I add them together, I get 1. I add the denominators, I get 2. That gives me 1/2, right? Well, does that make sense? Well, not entirely. 0 plus 1 would just be 1, okay? Well, now let's look at two more adjacent ones, right? Let's do 0 and 1/2. If I add the numerators, I get 1. If I add the denominators, I get 3. I get a 1/3. Well, if I was adding 0 plus 1/2, I would just get 1/2, right? So this process works for each pair of adjacent Fairy sequence numbers. And as you can see, this thing proceeds along. We go down here to this last row here, right? You see a lot of unit fractions. I'll make that connection here just in a moment. And you see these other various fractions that are ranging from 0 to 1. Now over here on the right-hand side, what you see is really the same thing, except now we're just using dots to illustrate. So that's the same thing. So we call that the sowing of seeds, or that's what the author uses, is called that the sowing of seeds. So let's move on. So in that Fairy sequence, right, those red dots that we saw on the previous slide, if at each of those red dots I initiate a circle that grows in radius up until the point that it touches tangentially another circle and then it stops, at that intersection, at that point of tangency, we're going to create now a new circle at that location, and it's going to grow until it touches another circle. Once it does, that intersection will be the new seed point, the new starting of a seed, and then a new circle will drop, and it grows. And you may have seen this at some other, either in a math class, you may have seen it in a geometry class, somewhere you may have seen this online, right? So this is actually pretty cool, but these are forward circles, and that's kind of how they are created. Now that brings me to fractal geometry. Now here is where we have the Mandelbrot set. So what we see is we got a cardioid over here. Now what we notice is we have these major bulbs, okay, these big circles that kind of are on the circumference of this cardioid. But look at the location of each one of them, right? 1/5, 1/4, 1/3, 2/5, going around from 0 to 1. That corresponds to that fourth row in the Fairy sequence. So that's actually pretty cool, right? And it appears for both, not just the position of the bulbs, but the structure themselves, okay? Now let's look on the next slide. If I kind of zoom in on that 2/5 location on the cardioid, what I see is out here there's an antenna, right? Well, here's what's unique about it, is if I take the antenna that kind of leads, or the antenna that leads out, the spoke that leads out to the major part of the antenna, if I start there and I count 1, 2, this smallest antenna of all of them is the numerator. And that I have a total of 5 spokes, that's the denominator. Now you may be saying, well, no big deal. However, that is a big deal because it occurs on all the other bulbs. Coincidence or strange pattern? Maybe. Now the math history connection here really is, as I said earlier, you see some unit fractions, what the Egyptians did. There's also counting involved in that. So it's really kind of from a fraction point of view. So that's the connection I would make to it, is really through the Egyptians. Lastly, I think this was a great article, mainly for the purpose, really, to engage a reader in a short journey of how a common mistake from grade school math, adding fractions, is actually a way to think about higher complex mathematics. Lastly, my citation, please go check it out. I think it's pretty cool. I'm going to use it next year in my class. Y'all have a great evening. Bye-bye.